Alright guys, so we're going to go ahead and get started with day 46. So we have learned day 44 was all about solving systems by graphing equations. Day 45 we graphed inequalities, right? So everything we've been dealing with so far has been graphing. And so now we're going to kind of get away from the graphs for a little bit. We're going to learn how to solve systems using a method called substitution. Some of you guys might have seen this before, but if you haven't, we're going to kind of talk about that today. So in your chart at the top of your notes here, you can see that there are two equations here, right? We have x equals negative 4y plus 12. We have 2x minus y equals 6. So with substitution, the way we want to start this, okay, we're going to solve for either x or for y. And so my x is already solved for, right? My x is already solved for here, and so I'm going to go ahead and write that down. That's going to be my first box here. X equals 4y plus 12. I don't have to do any work here, right? Because x is already solved for. I know that we're used to solving for y, but with substitution you can solve for x or for y. It's up to you which one you'd like to solve for. Okay, x is already by itself here, and so we're good to go with that first equation. Okay, now we have step number 2. We're going to substitute that answer that we just got in step number 1. We're going to substitute that equation into our second equation. Okay, and so here is our second equation, right? 2x minus y equals 6. Well, we know what x is, right? We already know what x is, and so we're going to substitute that into this second equation. So watch what I do here. 2x, right? But we already know what x is, and so I'm going to plug in negative 4y plus 12. That's what x is, right? I already know that from step number 1. Then I'm going to finish writing that second equation. So minus y equals 6, okay? So we now have substituted that answer in for x into that second equation, right? Now we're just going to solve, right? We're just going to solve for y, right? So we've already solved for x, right? That's already done for us up here in step number 1. Now we're going to solve for y. And so I'm going to distribute. I get negative 8y plus 24. And then I have minus y equals 6, right? I'm going to combine my like terms. I have negative 8y minus y. That's going to give me negative 9y plus 24 equals 6. I'm going to come up here. I'm going to subtract 24 from both sides. I'm going to be left with negative 9y equals negative 18. And finally, divide by negative 9. And I now have y equals 2, right? And so I have figured out what y is. The only step that's left, right, is to solve for x. And so I'm going to take that y, which is 2. I'm going to plug that into either the first or the second equation. It doesn't matter which equation you plug it into. You should get the correct answer no matter what equation that 2 goes into. And so I'm going to pick the first equation. We'll go back to that very first equation, x equals negative 4y plus 12, but now I know what y is, right? I already figured out what y is, and so I'm going to plug in y, which is 2, and so I'm going to replace y with 2 plus 12, and so I go over to here now. I have x equals negative 8 plus 12, and so x is equal to 4. And so I'm going to box my x, I'm going to box my y, right? I'm not quite finished yet though. Step number 5 says solution should always be a coordinate pair, right? We talked about this. When we graphed two lines, our answer was that intersection point, right? And so we do still have to write it as a point. And so I have my point x comma y, 4 comma 2, right? And so that's going to be my answer. So that's what substitution is, okay? And so we're going to just do a few more examples of that just to kind of get the ball rolling a little bit here. So step number 1, or problem number 1, sorry, we're going to use the substitution method. So again, it doesn't matter which equation we choose to start with here. I'm going to use this first equation. I already know what y is equal to, right? And so I don't have to do a whole lot here. So I'm going to plug y into the second equation. And so here's my second equation, x plus 2y, but we know what y is already. I'm going to substitute that in. Negative 1 over 2x, negative 1/2 x plus 3 equals 6, right? And so I'm plugging that in for y, okay? And so now I'm just going to distribute. So I have x, I need to leave that as is, right? And I'm going to go ahead and distribute now. So I have 2 times negative 1/2. That's just going to give me negative 1, right? My 2's are going to cancel out, and I'm left with just negative x, right? And so instead of x plus, I can go ahead and write x minus 1x, right? Or I can just write x minus x, okay? You don't have to put the 1 out in front. x minus x, and I'm going to distribute the 2 to the 3, and so I have plus 6, okay, equals 6. All right, what's nice about this, you guys see what happens here, x minus x, all I have left is 6 equals 6. Well, guess what? I don't have to take this equation, this problem, any further. 6 equals 6, that's a true statement, and so I can write infinitely many solutions. And I want us to get used to saying this for substitution, for solving systems in general, rather than using all real numbers. Let's kind of get into the habit of saying infinitely many solutions, because that's what it means, right? That means I can plug in any x or y value, any number for x or y, and I'm going to end up getting that the two sides are equal to each other, right? And so that's what infinitely many solutions means. Perfect. All right, so number 2. We have to solve for either x or y. That was our first step from our chart at the top of your notes there, right? We have to solve for x or for y. Unfortunately, in this problem, we don't have x or y solved for yet, and so we've got to do a little bit of groundwork before we can get started, right? So I'm going to take this second equation right here, and I'm going to subtract x from both sides, right? I'm going to solve for y. We're used to doing that, and so let's just make it easy for ourselves. Y equals negative x plus 5, right? And so now I can take this equation, this y, and I can plug it in for the y in the first equation, right? That would have to be my next step here. So 3x plus 2y, but we know what y is, right? We know what y is. I'm going to replace the y with negative x plus 5 because we just figured that out, right? That's what y is equal to. Equals 13. And I'm going to go ahead and distribute, so I have 3x, and I'm going to distribute the 2, right, into everything. So minus 2x plus 10 equals 13. Okay, and I'm going to combine my like terms. 3x minus 2x, that's just going to give me 1x plus 10 equals 13. And subtract the 10, I get x is equal to 3. Now that I have x is equal to 3, we're not done yet, right? I need my y. So I'm going to go ahead back into either of the two equations. I would say that second equation's probably a little bit easier to use. X plus y equals 3, right? I'm going to plug that 3 in for x. Oh, I'm sorry, x plus y equals 5. My fault. X plus y equals 5 is the second equation, right? Hopefully you guys caught that mistake. So I have 3 plus y equals 5. Well, you know, 3 plus what gives me 5, right? It's 2, right? I'm going to subtract 3 from both sides. I get y equals 2. So here's my x, here's my y, and remember we write our answer as a coordinate point, and so our point is going to be 3, 2, x, y, right? And so that is our solution. Guys, check your answers, right? Plug in 3 and 2 for both of the equations. Make sure that it works for both. Check your answers, okay? Please, please, please. I know that you guys don't like doing that, but please check your answers. It helps, okay? I am going to go ahead and erase what we just did for numbers 1 and 2, so hopefully you guys have what you need here. If you need to pause the video for a second, go ahead and pause it, but I'm going to go ahead and erase this, and we have number 3. So for number 3, I'm going to take the first equation. That's going to be a whole lot easier to work with, right? So I'm going to subtract 2x from both sides, and so I now have y is equal to negative 2x minus 1, right? Make sure your signs stay the same there. I'm putting it into y equals mx plus b form because, again, that's what we're used to, right? So I'm going to take that y and I'm going to plug it into the second equation here. And so negative 6x minus 3, we know what y is, right? Hopefully we're starting to get the hang of this now. I'm going to substitute y into that equation, right? This is the substitution method. So I'm substituting negative 2x minus 1 in for y, right? And so I no longer have to worry about a y being there. And so now I'm just going to solve, right? So I have negative 6x. Hopefully we know here that we're distributing a negative 3, right? Not just a positive 3. We're distributing a negative 3 into the parentheses here. And so I have positive 6x, positive 3 plus 3, right, equals negative 15. Okay? My 6x's, those are going to cancel out, and I'm left with 3 equals negative 15. That is obviously not a true statement. 3 is not equal to negative 15, and so our answer, we know this by now, is no solution, right? And so I don't have to take this any further. I don't have to write the answer as a coordinate point, right? I know that that's my final answer, and so I'm done, okay? So go ahead and flip over your notes now. We're just going to do a few examples of some word problems here. Hopefully these won't be too difficult for you. Obviously, for solving systems, right, systems of equations, we need 2 different equations. So for each one of these word problems that you see here, numbers 5, 6, and 7, we need two different equations. Okay, and so the first one says Max collects baseball and football cards. The number of baseball cards is 10 more than twice the number of football cards. I think by now we know kind of what that means. That's our translating expressions, right? So 10 more than twice the number of football cards, right? So twice the number, that's 2 times, right? So 2 times F, I'm going to just use the letter F for football, twice the number of football cards, and then 10 more than that, right? So plus 10, okay? And again, that is, what is that? That's the number of baseball cards, right? And so that's what B is equal to. So 2F plus 10 is equal to B, right? Because it says the number of baseball cards. I should have underlined that before. The number of baseball cards, so that's our B, right? That's our B, is 10 more than twice the number of football cards. And so we should be okay with that first sentence, with that first equation now, sorry. Finally, we have our second equation here. It says altogether Max has 70 cards. This is a very important part of our equation here. And I'm going to actually just switch this around just for a second here. Don't be confused at what I'm doing. I'm going to put the B out in front here. So B is equal to 2F plus 10. That means the same thing. Okay. Now, altogether he has 70 cards. So that's going to be my total, right? Equals 70. And if there's baseball cards and football cards, and we don't know how many of each type that Max has, because that's what the question is asking us, we're just going to write B plus F, right? B plus F. So the number of baseball cards plus the number of football cards is equal to 70 total cards, and that's our total, right? So, substitution method, right? I have my B. Look, I just checked off that first equation, right? I have my B all ready for me, and so I'm going to substitute that B down here into this B, right? And so I'm going to put this in parentheses, 2F plus 10. That's my new B, right? And then I also have to finish off that equation there. So plus F is equal to 70, okay? And I'm going to combine my like terms, right? So 3F plus 10 is equal to 70. And I'm just solving this now, right? Minus 10 from both sides, subtract 10. I have 3F is equal to 60. And I'm going to divide by 3. So F is equal to 20, right? I'm not quite done yet though, right? It says how many of each type does Max have. So if there's 20 football cards, right? There's 20 football cards. That's part of my answer, right? 20 football cards, okay? We have to figure out how many baseball cards there are, okay? And so let's figure that out. Let's take the first equation here. I have I'm going to actually use the second equation. It doesn't really matter which one you use, but I'm going to use the second one. I have B plus F is equal to 70. Well, I know what F is now, right? B plus 20, right? I know that football cards, there's 20. So what plus 20 gives you 70, right? We should know that that's going to be 50, right? So there are 50 baseball cards, and that's going to add up to be 70. And again, guys, check your answers. If you want to plug in 20 and 50 to your first equation, make sure that the two sides equal to each other, right? Then at least you know that you did it correctly. You don't have to worry about making a careless mistake, right? Okay, so that's number 5. All right. And again, guys, if you have any questions on this right now, if it's a little bit confusing, we'll talk about it next week when you see me again, okay? Number 6, Shannon has a collection of quarters and half dollars, okay? She has 12 more quarters than half dollars. So 12 more quarters than half dollars, right? And so that means that quarters, right? We know that there's 12 more quarters than half dollars. So I know H plus 12, right? I know that there are however many half dollars she has, there's 12 more than that. That's how many quarters there are total, right? So our quarters is our total there. Okay, the second sentence, the total amount in her collection is $13.50. That's going to create my second equation, right? So my total is $13.50. Okay, I'm not just going to write Q plus H like I did in the last problem, though. This is a money amount, so I need to make sure that I write exactly how much a quarter and a half dollar is worth, right? So I know that a quarter is 25 cents, so I'm going to write 0.25 Q. Okay, I know that a half dollar is worth 50 cents, right? And so I'm going to write 0.50 H, and I know I had to squeeze that in there, so sorry. 0.25 Q plus 0.50 H is equal to $13.50. So there's my two equations. It asks me how many of each type of coin does Shannon have, and so I'm going to go ahead and I'm going to plug in this Q that I have right here. Q is equal to, And I kind of drew that arrow in the wrong place there, but I'm going to take that q and I'm going to plug it into the q that you see down there, right, into that second equation. And so 0.25 q, but I now know what q is, right? It's h plus 12. I'm substituting, right? That's all about today's lesson is substituting, right? So I'm going to plug in h plus 12. I'm going to replace that substituted in for q. Plus 0.5h equals 1350. Okay, and so now I'm going to distribute 0.25h plus what is a quarter of 12, right? 0.25 times 12, that's going to give me 3, plus 0.50h equals 1350. Okay, I'm going to combine my like terms. I get 0.75h. I know I'm getting down to the bottom of the board here, so make sure you can see what I'm doing here. 0.75h. I'm going to subtract 3 from both sides, right? I do have to do that. So that's equal to 1050 now, right? And finally, I'm going to divide 0.75 on both sides, and I'm going to end up with h is equal to 14. That's how many half dollars I have. So now we need to go back to the very first equation we have here, which was q is equal to h plus 12. I'm going to plug in 14 for h. And so I have 14 half dollars, but then I have 14 plus 12. So I have 26 quarters, right? And so there's 14 half dollars, 26 quarters, and that's how many of each type of coin that I have, okay? Again, if you need to pause it for a second to kind of look before we go to the last problem, please do so. Okay, now is the time to make sure that you kind of understand what's going on here, so that you are okay to do your homework, okay? All right, finally, number 7. Okay, we're almost there, last problem. All right, so again, there are 900 total people attending this school play, right? And so one of my equations here is going to be x plus y is equal to 900, right? We don't know how many of each type of ticket is sold, right? And so we're looking at, that's what the question asks me, right? How many tickets of each kind were sold, right? So there were 75-cent tickets and there were 50-cent tickets, right? So I have x, we're going to put up here somewhere, x equals 75-cent tickets, right? And y is equal to 50-cent tickets. Make sure you write this, please, so that you know what x and y are, right? X is 75-cent tickets, y is 50-cent tickets. All right, so I have x plus y, the total number of tickets. That's obviously going to equal 900 because there are 900 total people attending the school play. My second sentence now is going to deal with money. We talked about this, right? 75 cents for the tickets, 50 cents for the other tickets. Our total amount is $520. So we know that 520 is our total amount. And so then we're going to put 0.75x because that's how much one type of ticket costs. Another type of ticket is 50 cents, right? So we're talking about maybe, you know, better seats. Maybe those are why those are 75 cents instead of 50 cents, or maybe as it got closer to the play, maybe they lowered the price of the tickets, and that's why some cost 50 cents, right? And so that's why there's two different prices for the tickets. All right, and so again, I am going to have to do that one extra step for this problem. I'm going to have to solve for either x or y. Don't work with that second equation. There's no point in working with that. That's tough. That's a longer equation to work with. So just work with that very first equation here, right? I'm going to solve for y because we're used to doing that, right? Subtract x from both sides. I end up with y equals negative x plus 900. That is what I am going to substitute in for y in the second equation. So let's move on to the second equation now. 0.75x plus 0.5 y, but I know what y is now, negative x plus 900, is equal to 520. Okay, and so I'm going to go ahead and distribute now, right? And when I distribute, let's slow down a little bit here. When I distribute, I'm going to distribute the 0.5 into both terms inside the parentheses. So this is going to end up being minus 0.5x plus 450, right? And this is equal to 520. So I'm going to combine my like terms. I get 0.25x. I'm going to subtract 450 from both sides. And I end up with 0.25x is equal to 70. And I'm going to divide, again, I'm getting to the bottom here, make sure you can see what I'm doing. I'm going to divide 0.25, and so I end up with x is equal to 280. That's how many 75-cent tickets were sold. You got to do that last step, guys, right? Look back at the very first equation. X plus y is equal to 900. I found out how many 75-cent tickets were sold. Now I need to find out how many 50-cent tickets were sold. So I'm going to plug in 280 for x because that's what I just figured out there, right? Is equal to 900. I'm going to subtract 280 from both sides, and we can see that y is going to be equal to 620 tickets, right? And so that's how many 50-cent tickets were sold, and up here we box our x. That's how many 75-cent tickets were sold. Again, if you labeled at the top of your paper what x and what y is, then you don't have to label at the end. I already know what types of tickets you're talking about if you labeled it at the beginning, okay? All right, I know this was a long day for you guys. You had a quiz, you had notes, and so whoever is subbing for you guys today, they will pass out the homework now. I will see you all on Tuesday. Please make sure you have all of your homework so that I can check off on everything when we get back from the 3-day weekend. All right, thanks for listening, guys.